For the 53rd problem on the second ACT practice test, a function p is defined as follows. For x greater than 0, p of x is equal to this equation here, though for x less than 0, p of x is equal to a slightly different equation here. What is the value of p of negative 1? So we have to figure out what p of negative 1 is. And remember, when dealing with functions, especially functions of x, whatever is in here is essentially what we're substituting for x. So in our case, x is equal to negative 1, and we need to evaluate the function at this x value. So going back to our definition of the function, for x bigger than 0, we have to use the top one, but we have an x value that's less than 0. So that means that we have to use this equation here. So let me rewrite it. So we have p of x is equal to minus x to the 5th plus x to the 4th plus 36x minus 36. And now, all we're really doing is anywhere we see an x in here, we're going to replace it with this negative 1. So we need to evaluate what p of negative 1 is. And my advice when plugging in negative 1 for x, or anytime you're plugging in a negative number, it's usually helpful to put it in parentheses. And that'll just make sure that you don't lose track of your signs. So we have negative 1 to the 5th power plus, here we have it, negative 1 to the 4th power. Then we have plus 36 times negative 1 and minus 36. So at this point, we just have to simplify and evaluate. So our p of negative 1 is equal to this minus negative 1 to the 5th power. So if you multiply negative 1 by itself, let's see, twice, so negative 1 squared, this is just minus 1 times minus 1, and here, two negatives multiplied together give you a positive. So every pair of negative 1s multiplied together, you get a positive number. But for an odd power, so negative 1 multiplied by itself an odd number of times, you're not going to be able to pair up one of these negative 1s. So what you end up with is just negative 1. So if that didn't make sense, negative 1 to the 5th power is just negative 1. And if you put this into your calculator with parentheses, you will get back negative 1. So with that in mind, this minus sign would still be with us in front, and then negative 1 to the 5th power was just negative 1. So we have minus negative 1 here. And then plus, now negative 1 to the 4th power. We essentially have two pairs of these negative 1s. So it's very similar to this here, but we would have negative 1 times negative 1 added to it. But keeping in mind that each pair of negative 1s would cancel out and give you a positive 1, we would have that happen twice. So the end result is that negative 1 to the 4th power is just positive 1. So we're just adding 1 here, and then we have plus 36 times negative 1. 36 times negative 1 is negative 36. So instead of adding negative 36, we can just write minus 36, and then we have to subtract 36 again. So from here, we have that p of negative 1 is equal to minus negative 1. So if you ever have two negative signs in a row, you can just change them to plus signs. So this becomes positive 1. So subtracting a negative is the same thing as adding. And then plus 1 and minus 36 minus 36. But subtracting 36 twice is the same thing as just subtracting 72. So this problem essentially becomes this minus 72 plus 1 plus 1. So that evaluates to minus 70. So our function p, evaluated at negative 1, is simply equal to minus 70. And you can see that that is choice letter A here.